Now in this video we are going to talk about integration as antiderivative, which we actually said in the first integration video. But now let us just have a look at the formulae which can directly be used. Now if my y and dy by dx, so if y is x raised to power n, then dy by dx is n into x raised to power n minus 1. Y is sin x, dy by dx is cos x. Y is cos x, it is minus sin x. Y is tan x, it is sec square x. Okay, and then we have other formulae. Now what you can do is you can just take the derivative and then go back to the main function, which will give you integration. So what I mean to say is integral cos x dx is equal to sin x, and we have to add that constant c. Integral sin x is minus cos x plus c, and so on. Okay, integration of x raised to power n dx is equal to x raised to power n plus 1 upon n plus 1 plus c. Okay, this formula. Now what about integral 1 upon x dx? Now here, over here, n is not equal to minus 1. That means if x is 1 upon x, then we won't be using this formula, but then we would be using this log of x, because derivative of log of x was 1 upon x, right? And never forget adding the constant. But then in physics you will be dealing with some values, so definitely you are going to do definite integration, not indefinite one. So that is about integration as antiderivative. Maybe you can see this later also. Now I want to do some actual integration in physics. How do we do that? The velocity of a particle, okay, v is equal to, now it is given in terms of time. Okay, so it is 3x cube. I'll instead of x I have to take time, correct? So it is 3t cube minus 4t square plus 8. Okay, that many meter per second. Now we are using derivative as well as integration. So I want to find the acceleration. Okay, so my acceleration is, I would say at t is equal to 3 seconds, and displacement at the end of 3 seconds. Now here, from velocity, getting acceleration is quite easy. You find the derivative of velocity. So my v is equal to 3t cube minus 4t square plus 8. So dv by dt is going to be 3 into 3, 9t square minus 8t plus 0. So 9t square minus 8t. And now I want acceleration at t is equal to 3 seconds. Acceleration is variable. It is function of time here. It is function of t. It's not constant. So it is going to be changing. So I am going to substitute t is equal to 3 here. So 9 into 9 minus 8 into 3. Correct. So it is 81 minus 24, and that would be 61 minus 4. So that would be equal to 57 meter per second square. Okay. Now getting displacement from velocity. Now what is my velocity? Velocity is equal to ds by dt. Correct. So I can say ds is equal to v dt. Right. So now for getting displacement, I need to integrate ds, and so I integrate even the right hand side there. And what are my limits? displacement at the end of 3 seconds. So I start from t equal to 0 to t is equal to 3. Correct? This is my limit. So then this is going to be, therefore, integral ds. Okay, integral ds is going to be equal to s is equal to integral 3t cube minus 4t square plus 8 dt. Correct. So what is integral 3t cube? So it would be 3 into t raised to power 4 upon 4 minus 4 into t raised to 3 upon 3 plus 8t, and then that between 0 to 3. So it is 0 to 3 here. My lower limit is 0, upper limit is 3. Now obviously when my lower limit is 0 and everywhere you have a term in t, it is t or t square or t cube or t raised to power 4, correct? So here I am going to have 3 into 3 raised to power 4 upon 4 minus 4 into 3 raised to power 3 upon 3 plus 8 into 3. So whatever is the value that you can calculate using your calculators. So now here what we basically learned is application of calculus in physics. So I have been given velocity. If I integrate velocity, I get displacement. If I differentiate velocity, I get acceleration. Now one thing which I would like to finally say about this is, in kinematics, okay, I have been given a graph. I have been given graph of displacement with respect to time, velocity with time, okay, and the graph is something like this. Okay, this graph may be something like this. Here my graph of displacement with time is a straight line. Is it not having constant gradient? So if the gradient is constant, if the graph is a straight line and gradient is constant, then that means my velocity, gradient of displacement time graph gives you velocity. Okay, so this is gradient is velocity. What if my displacement time graph is a curve? Then the velocity at some particular point, that will be given by gradient of tangent to the curve at that point. Okay, just keep this much in mind. Okay, what about velocity time? Now here the gradient is acceleration. Okay, but now if you find the area under the velocity time curve, then this area, that would be giving you displacement. Okay, likewise if you have a graph of acceleration with respect to time and it is like this, something like this, then area under the curve, okay, that would give you average velocity, right? So this is application of calculus in kinematics. Mostly you'll be using this in kinematics and mechanics, right? So that was all about calculus in physics. If you have any doubts, you can just put that in comment section, and I'll try and answer them. Thank you so much.